Hi guys, so today we're going to talk about discrete domain and range. A discrete graph consists of individual points, okay? Discrete data would be individual points as well. It would be just individual coordinates. Domain always refers to your x values, and range always refers to your y values. So the domain and range are listed as a set of values or as intervals with restrictions, okay? Now, we don't normally, most of the time, we're going to just list the set of values. But if we do an interval with restrictions, we're talking about like, we might do x is less than 7, but only integers, okay? So it could be any integer that's less than 7. Okay, that would still be considered a discrete graph or a discrete domain and range. All right, so we're going to talk about a couple of examples. We've got an example with the graph here. So for each of these relations, and remember, relation is just a set of ordered pairs. For each of these relations, we're going to identify the domain and range and decide if it's a function or not, okay? So we're going to start here, this first one, and I'm going to number these 1, 2, 3, 4, 5, 6, and 7. Just so you see, we have 7 points, and I'm going to, when I write the ordered pairs, I'm going from point 1 to 2 to 3 to 4 to 5, 6, and 7. You don't have to number the pairs, but or the points. I just did to make it a little easier, so you know where I'm starting. So number 1 is at -7, 6. Okay. And number 2 is at -6, 1. Number 3 is at -5, 4. Number 4 is at -3, -1. Number 5 is at -1, 3. Number 6 is at 2, -2. And number 7 is at 4, 1. Okay. So now we're going to talk about domain and range for these. Okay. So domain values are going to be all of our x values. Okay. Actually, let me change colors here so we can kind of have a little bit of color coding going on. Okay. So our domain values, like I said, are going to be our x values. Now, when I write this, I'm going to write this using set notation. So this is just a bracket. It's actually called a brace. It's not a bracket, but it's called a brace. So we're going to use the brace and say x is equal to. And then we're going to list our x values. Now, we always list them from smallest to largest in order. And if a value repeats, we only write it one time, just like we do on our mapping. Okay? So when we have a graph, it's really easy. We just kind of start on the left and look at each of the x values we use. So point number 1, use the x value of -7. So that's going to be our first one. And then -6. And then -5. And then -3. -1, 2, and 4. Okay. With our range is going to be our y values. Okay. So our y values, we're going to do the same thing with them. We're going to list them from the lowest value to the largest value. And if that value shows up more than one time, we're only going to write it one time. Now, again, on a graph, it's fairly easy. We just start with the lowest point, this one, which is at -2. And then we just kind of work our way up. So -2, then -1. And if we jump up here, and you see at 1, we've got 2 points here, but we're only going to write one time, okay? And then we jump up here, and this one is at 3 for the y value, at 4, and our last one is at 6, okay? So that's all we're doing to write domain and range. We're just listing the x and y values. Okay, is this one a function? Well, to decide if it's a function, you just need to use a vertical line. Okay, so I'm going to draw a vertical line using my little tool here. I pick, oops, sorry, let me insert my line again. I'm going to draw a vertical line, and then we're going to use this vertical line to decide if we have a function or not, okay? So if I take this vertical line and I move it to any of my points, and I move it along my graph, we'll see that at any point along this graph, it only hits one of our numbered points, okay? So since it only hits one of our numbered points, then yes, it is a function. So yes, it is a function, okay? So we can move on to our next one. Let's look at number 2. Now, number 2 already gives us the points. We don't have to worry about looking at a graph or anything. We have our points, okay? So let's look at our domain, again, is our x values. So if I look at my x values, I've got a 1, a -2, a 1, a -4, and a 2. Okay, so the lowest x value I have is -4, and that's the one I'm going to start with. X equals -4. And then the next lowest value I have is -2. So -2. And then after that, the next lowest I have is 1. Now look here, 1 happens twice, here and here, okay? But I'm only going to write it once. And then last, we have 2. So we're going to put our 2 in there. And that's our domain, okay? Our range, we're going to look at the y values. Okay, range is the y values. So I've got a y here, 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 and here. Okay, and again, lowest value to highest value, repeaters, we only write down one time. Okay, so our lowest y value is at -3, and then it jumps to 5, 6, 8, and then 9. Okay, now we need to decide, is this a function or not? Okay, now if you remember on Monday, we said that in order to be a function, the x values cannot repeat. So since this one repeated, then the answer is no, it is not a function. And the reason is x repeats at 1. Okay, that's all the reason you need. Okay, now it does say, if we look back at our essential question over here, how can you check to see if a graph represents a function? This is where we're going to use our vertical line test. Okay. Now, for me, it was easy to use a vertical line test because I just, drew a quick vertical line using the tools um, on Word. But you can use a pencil. You can use, you can even look at the lines on the graph, the vertical lines on the graph. If any of the vertical lines on a graph go through more than one of the points, then it's a discrete line, or it's then it's not a function. Okay, but these are all discrete relations, and if they happen to be a function, then they are also a discrete function. Okay. All right. So now we have a mapping. And again, we want to create some ordered pairs from this mapping. So let me go back to this color. So we're going to start, remember this is our X and our Y for our mapping. Okay. So our ordered pairs, we start here, we've got 2, and that goes to 12. But we've also got 2 going down here to -3. We've got 1 going to 5, 0 going to 0, and -1 going to 5. Okay? So now let's look at our domain and range. Now, finding domain and range on a mapping is really easy because they're already done for you. You just have to rewrite it. Okay? So again, we're going lowest to highest in order. Okay? So the mapping has it from highest to lowest. We're going to go lowest to highest for our domain. So -1, 0, 1, 2. All we had to do was rewrite this box right here, or this oval right here. Okay. Now for our range, we're going to do the same thing, but with the other oval. So y equals -3, 0, 5, 12. Okay. And that's our domain. Now, is this a function? The answer is no. It is not a function. Okay? It's not a function because our 2 repeats. This 2 right here has 2 arrows that come off of it, so it's not a function. Okay? X repeats at 2. Okay? You can also say something like X equals 2 has more than 1 arrow. Okay? Both reasons are valid. Okay? So if you're checking to see if a mapping represents a function, if it has more than 1 arrow, it's not a function. Okay? If an X value has more than 1 arrow, it is not a function. All right. So we have one more example to look at, and that is this table. Cost of admission to Waterworld. Okay. So again, we need to set up some ordered pairs. We're going to get those from the table itself. Okay. So we're going to come over here. And our ordered pairs, we're going to start just by putting our pairs together. So 1 and 28. Our pairs are already put together for us. We just need to put them in the ordered pair format. 2 and 50, 3 and 80, and 4 and 100. Okay. Once again, on a table, it's really easy to find domain and range. Okay. Because they're kind of already lined up for you. The left side of the table is going to be your domain. And in this case, they're already in order for us. That's not always the case because they don't have to be, but in this case they are. So 1, 2, 3, and 4. And then for our range, that's our y values. Okay. So again, we just have to rewrite them. We just need to make sure they're in order because they're not always going to be in order from least to greatest. In this case, they are, but sometimes they may be all out of order, or they may be going from greatest to least. So you just need to make sure you put them in order. Is this a function? Yeah, it is. Okay, we do not have any values that repeat on the x column. Okay, this is the column we look at to see if it's a function. And yes, it is absolutely a function. Okay, no explanation needed there. All right, guys, you have an assignment in your packet where you are looking at various discrete relationships, and you need to decide if they are functions or not, and give me a domain and range for each one. All right, I will see y'all tomorrow. Bye.